I welcome you all to my channel Engineers Academy. Kindly subscribe my channel if you haven't subscribed it yet. Now we are going to solve this problem which says that determine the location of the centroid of this homogeneous rod. So we have to find x bar, y bar and z bar of the centroid of this homogeneous bar. So as we know that x bar, this is equal to the summation of x tilde times L divided by the summation of the length, that is the total length of this homogeneous rod. Similarly, we can write that y bar, this will be equal to the summation of y tilde's time L divided by the summation of length, and similarly z bar, this is equal to the summation of z tilde times L divided by the total length of that rod. So to find the centroid of this composite shape or body, we have to divide this into different segments. So let's say this is our segment 1. Let me write that this is segment 1, this vertical portion. Then this horizontal portion is segment 2, let's say. And this third vertical portion is, let's say, segment 3. So the centroid of this sigma 1 will be at its mid length. So let's say this is C1. So it is located at a distance of 100 mm from that origin. From this origin, it is at a distance of 100 mm. So the centroid of this segment 1 is lying on the z-axis. So this means that x tilde 1 and y tilde 1 and will be equal to 0, and z tilde is, we can write that z tilde, the location of the centroid of this segment 1 along the z-axis is z tilde 1, and that is equal to 100 mm. So we have to develop that table. So we need to write segment, then we have to write the length, then x tilde, y tilde and z tilde, and then the product of x tilde times L for each segment, the product of y tilde time L for each segment, and the product of z tilde time L for each segment. So now this is segment 1, and segment 1 has a length of, total length of 200 mm. The units are in mm. Remember, this is in mm. All these are in mm. So x tilde is 0, as we know that the centroid of this segment 1 is on the z-axis. So x tilde is 0, y tilde is 0, and z tilde is equal to 100 mm. So I will write that this is 100. And now if we take the product, so this is 200 into 0, this is 0, and 200 into 0 again, this is 0, and 100 into 200, so this is 20,000. This is 20,000. Similarly, this is our segment 2. If this is our segment 2, so its centroid will be somewhere here. Let's say that centroid is C2. So if we drop a perpendicular from this C2 on the y-axis, let's say if this is C2, and if I drop a perpendicular on the y-axis, so, and if I drop a perpendicular on the x-axis, so this will be x tilde for this C2, this is x2 tilde, and this C2 will be at a distance of 300 mm along this length. So this is 300. So if we drop a perpendicular, then this x2 will be, this will be 300 cos of 30 degrees, and similarly this length will be, this will be 300 sine of 30 degrees. So this means that x tilde 2 is this, and this is y tilde of segment 2. So now we need to write segment 2. The length of segment 2 is 600, so I will write that this is 600, and x tilde 2 is 300 cos of 30. So 300 cos of 30, this is 259.807. Let me write that this is 259.808, and similarly y tilde of segment 2 is 300 sine of 30. So 300 sine of 30, this will give us 150. So this is 150, this is 150. And similarly, since this C2, the centroid of this segment 2 is lying in the xy plane, so the z tilde coordinate is 0. So we have to write that this is 0. Now we will take the product later. Now we will consider this segment 3. So its centroid is located somewhere here, that let's say that is C3, and it is again at a distance of half of the length. This is 50. This is at a distance of 50 mm, and as we can see that it is along this length, it is at a distance of 600 mm from that origin. So again the distance of the centroid of this segment 3 along the x-axis will be this distance. So this is, we can say that this is x tilde 3. So this length is 600, and if this is perpendicular, then x tilde 3 will be 600 cos of 30. And similarly, the y tilde of this C3 will be this much distance from here to here, this much distance, and this is 600 sine of 30 degrees. And similarly, as we can see that this C3 is at a distance of 50 mm in the downward direction, that is parallel to the z-axis. So this means that the x tilde 3 is this, and this is y tilde 3, and z tilde 3 is minus 50 mm, that is in the negative z direction, right? So we have to write that this is segment 3, and the length of segment 3 is 100 mm. This is 100, and x tilde is this 600 cos of 30, 600 cos of 30. This is 519.615. So 519.615, and then y tilde of 3 is 600 sine of 30. So that will give us 300. So this is 300, and z tilde of 3 is minus 50. So this is minus 50. Now we have to take the product, right? So we have to multiply 600 with this, and then 600 with y tilde. So 600 into 600 into 259.808. This gives us this value, which is 155,884, 155,884.8. And similarly 150 into 600, so 600 into 150, this gives us 90,000. This is 90,000. And similarly z tilde into L will give us 0. Similarly, we need to multiply this 100 with all these three. So 100 into 519.615. This gives us 51961, 51961.5. Similarly, 300 into 100, so that will give us 30,000, and 50 into 100, so this is minus 5,000. So now we have to add up this. So that will give us the summation of x tilde times L. We have to add up this. This will give us y tilde times L, and we need to add up this. This will give us z tilde times L. So now I have made a table for such kind of problems in Microsoft Excel. We can use that to calculate all these. So let me put all these values. Segment 1, 2, 3, length is 200, and that x tilde is 0, and y tilde is 0, that is 100. So it will calculate these values directly, since I have put the formula in Microsoft Excel. This is 600, and this is 259.808. So, and again this is 150, and this is 0. And similarly for segment 3, this is length is 100, and this is 519.615, and this is 300. And similarly this is minus 50. So now the summation of x tilde time L is 207,846.3, and the total length is 900. So if we divide this value by 900, we will get this. So that is, let me calculate it, that is 200, that is 20 27846.3. This is the summation of x tilde time L. This is the summation of this, and we need to divide it by the length, right? So we are using this formula. So that is divided by the total length, which is 900. So 900. So this gives us 230.9403. So x tilde is 230.9403. X bar is 230.9403 mm. Similarly, the summation of y tilde time L is this. This is 1,20,000, and if we divide it by 900, we get this 133.33 mm. And similarly, z bar is 16.667. So let me write all those values, or we can say that x bar is 230.94 in mm. Similarly, y bar is 133.33 mm, and similarly z bar is 16.67, that is 16.67 mm. So if we locate that centroid, so that centroid is, so from here to here, this length is, we know that this total length is how much? This is 519. So this is 519. So the centroid location of this bar along the x-axis is 230. So that will be somewhere here. Let's say from here to here, let's say this point is 230, and then along the y-axis that distance is 133.3. so let's say that 133.3 is somewhere here. Let's say that is somewhere here, and then in the z direction, so in the z direction, that is 16.67, so that is in the upward direction, so that is somewhere here, the location of the centroid. So this is the solution of this particular problem. I hope this will help you in your learning. Do let me know in the comments if it helps in your learning. Also subscribe my channel Engineers Academy if you haven't subscribed it yet.